In this video, we're going to look at how to predict what reaction will take place in a redox reaction using the 5-step method. We're going to walk through an example together. So a penny is a zinc disc plated in copper. If a penny is cut in half and placed in a solution of sulfuric acid, what reaction will take place and what observations might be made? So in this diagram that you can see, we have our pennies cut in half, and we have a beaker of sulfuric acid. And so what we're going to be doing is taking this penny and popping it into this beaker. The first step in the 5-step method is to list all chemical species present. Really important in doing this is to dissociate any soluble ionic compounds and to ionize any strong acids. So in this compound, or in this situation, we have present solid copper, the outside of the penny, solid zinc, the inside of the penny. We have H plus from the acid. So sulfuric acid is a strong acid. We're going to completely ionize it. And we have water. So these are all of our species that are present in this beaker, able to react. Our second step is going to be to identify any oxidizing agents and reducing agents using page 7 in the Chem 30 data booklet. In this table, oxidizing agents appear on the left side of the arrows and reducing agents appear on the right side of the arrows. So that provides us an easy way to sort. So I'm going to first go down and list all of my oxidizing agents. Really important here, don't miss any combinations. So something like H plus and water might be present together, and that might be something that we want to combine as an example. So our oxidizing agents, one of them is sulfuric acid itself. So SO4 2- with hydrogen ions is an oxidizing agent. The hydrogen ions by themselves are also an oxidizing agent. And water is an oxidizing agent. So those are our 3 oxidizing agents present. We're going to do the same thing for our reducing agent. So we're going to look on the right side of the table, and we're going to try to find any and all combinations that may be present together. Oh, I missed one oxidizing agent. So water and sulfate ions are also an oxidizing agent. Okay, so on the other side, we're going to start to identify our reducing agents. So zinc metal is a reducing agent, as is copper. Water is also a reducing agent, so it can both oxidize and reduce substances. And that is everything. Step 3 is going to be identifying the strongest oxidizing and the strongest reducing agent from the list created in step 2. So our strongest oxidizing agent is going to have the highest E0 value. It's going to be quite high. Our strongest reducing agent will have the lowest E0 value from that table on page 7. So looking at that table, we're able to rank and see that the strongest oxidizing agent is the combination of sulfate and hydrogen ions, and the strongest reducing agent is zinc. Our fourth step will be to write and balance the half reactions for the strongest oxidizing agent and the strongest reducing agent. We're going to get these directly from our book on page 7. So our strongest oxidizing agent is the combination of sulfate and hydrogen ions. So we have 1 sulfate plus 4 hydrogen ions. And this is an oxidizing agent, so it undergoes reduction, producing sulfurous acid, H2SO3, and water. Our strongest reducing agent is zinc. Zinc starts as a solid, and it forms zinc 2+ by losing 2 electrons. I'm going to quickly just write the E naught values for these two reactions. We're going to use that in the next step. So our E naught for this reaction is positive 0.17 volts. That's the reduction potential. And our E naught for this reaction is negative 0.76 volts. And this is our SOA and our SRA. So we need to balance these reactions against each other, and we're going to do that by making sure that the number of electrons lost is equal to the number of electrons gained. So if we look here, we lose 2 electrons in our zinc half reaction, we gain 2 in our sulfate half reaction. So that is good. We can add these two reactions together now. So our net reaction here is going to be sulfate plus 4 hydrogens plus zinc solid. It's going to produce sulfurous acid plus water plus zinc 2+. Our final step is going to be to predict the reaction spontaneity and any observations we might see. So to predict spontaneity, we're going to compare the E naught value of our strongest oxidizing agent to the E naught value of our strongest reducing agent. If the E naught of our SOA is greater than the E naught of our SRA, this reaction is spontaneous and will occur without any outside energy, specifically electrical energy. However, if our SOA E naught is less than our SRA E naught, this reaction is non-spontaneous. Now in this case, our E naught of our SOA is greater than our E naught of our SRA. That means that this reaction is going to be spontaneous and will occur as soon as we add the coin to the acid. So when we predict our reactions, we need to look at what actually happens. So we're not producing any gases in our state, so there will be no bubbles, but we are seeing a change in state from a solid to aqueous. And so what we're going to see happen is that the inside of the penny will dissolve. That's where the zinc is, and so the penny will be remaining as a basically hollowed out copper shell. And that's how you predict if a redox reaction will take place and then what you will see when it does.